Hi folks, Mr. Long here. I'm going to do a screencast for the intersection of lines and parabolas. We're going to look at this, which is a discriminant problem. We're going to try and figure out what the value of m is in the line to create either 0, 1, or 2 intersections between the line and the parabola below. So you can see the parabola right there, y equals x minus 4 quantity squared plus 24, and then the line has an equation of y equals mx minus 81. So there's one of these graphs that we can sketch pretty quickly because we have all the information, and that is the parabola. So if we look at it, we know the vertex is going to be at 4, 24, and we also can figure out the the y-intercept rather pretty quickly. So we know that along the y-axis, the value of x is 0. So if I replace x with 0, just where I've circled, we're going to end up with 0 minus 4, negative 4. We square negative 4, we get 16, and then add that to the 24, and the y-intercept is 40. Let's make a sketch. So 4 and 24, again, just a rough sketch so that we understand what's happening. Plot on that y-intercept of 40, and then draw our parabola. So there's the parabola, and then we know that the line has a y-intercept of negative 81, so it's probably way down here, negative 81. So if I want to think about a tangent, I probably have one right there, and then I'm going to have one that goes up fairly steeply right there. Okay, so that's what it looks like. Again, pause the video at any time, rewind, replay, etc. All right, so what I need to do is figure out when the distance between those two is 0, because if the distance between is 0, then I have a point of intersection. Okay, so we have the y value on the parabola minus the y value in the line equal to 0. Okay, so, and what I'm going to do is just quickly expand that out. So that expansion is going to be, for the parabola, it's going to be x squared, and then it's 2 times negative 4 times x minus 8x. Then I have to square the negative 4, that's 16. Add to the 24, I've got 40, which I already had for my y-intercept. Now I have to subtract off that line, so minus mx, and then the negative 81, I subtract negative 81, which is plus 81, and that equals 0. So now I collect like terms. The negative 8x and the mx are like terms. X squared minus 8x minus mx plus 121 equals 0. A, B, and C. So for the tangent condition, one solution, I know the discriminant is 0. Discriminant is 0. So in other words, b squared minus 4ac is 0. B is worth negative 8 minus m, it's the coefficients in front of x, squared, minus 4, a is 1, and c is 121. That has to be 0 for a single intersection point. Negative 8 minus m, quantity squared, minus 4 times 121. Well, 4 times 100 is 400. 4 times 20 is 80. So that's 484 because I had to add the extra 4 ones. And that equals 0. To solve that equation, I add 44 to both sides. Negative 4 minus m, negative 8 minus m squared will equal 484. And then I square root both sides. Here I suppose I should have put plus 484 on both sides. Then I'd have negative 8 minus m will end up equaling plus and minus root 484. And that would be 22. So this is a bit of a weird one, right? So because I don't want to have to divide by negative 1, what I can do is add m to both sides. So that brings the m over here. And then I'm going to have negative 8 plus or minus 22. Because when I add, I've got to get rid of that. I've got to get rid of the negative plus and minus 22. Well, the opposite of plus and minus 22 is minus and plus 22, which is the exact same thing, right? So now what are my two values? Well, the m value that's to the left will be negative 8 minus 22. Negative 30. The m value to the right will be m2, and that will be negative 8 plus 22, which is 14. Those are our two slopes. So just to again draw a sketch of that, here's our scenario. So we have a positive slope here, 14, and then a negative slope there of, of 30, negative 30. Okay, and the whole idea here, let me do the parabola in a different color. So these are points of tangency, so there's a single intersection. So what I need to do is figure out, well, what are the values that create no intersections, okay? One intersection is easy. It's negative 30 and 14. Those two slopes will give me one intersection. But what are the slopes that create no intersections? So what I'm going to do is just draw another line here. That it will have no intersections. That line would have no intersections. That line would have no intersections. And those slopes might be like 13, 12, 11. And then on the other side, if I do no slope, no intersections, those are like negative 29, negative 28, negative 27. So the slopes are less and less, right? So what is that number set? If I think about it, that number set, 11, 10, 9, 8, 7, 6, and so on, dot, 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 negative 23, negative 24, negative 25, negative 26, you can see that it will go right around. So that's a number set that joins. So I get no solutions. So there are no solutions, or zero solutions, if m is in between these two numbers, as low as negative 30 and as high as 14. Okay, there are no solutions. Well, that tells me that I've definitely got two solutions then with any other sort of value. So let's take a look at that here below. So I'll draw the parabola there, and I'll draw my two tangents. Tangent coming down there, tangent coming down there. And this tangent slope on the left was negative 30, and the tangent slope on the right is 14. So how would I get two intersection points? Well, slope of 14, slope of 15, slope of 16, all the way up to where it's vertical, which is positive infinity. So this one is 14 all the way to positive infinity. And that will give me two intersection points. What about the other side? The other side would be negative 30, and then negative 31, negative 32, negative 33, all the way up to negative infinity. So for this one, and so here's the instinct, is you're going to write, oh, well, it goes from negative 30 to negative infinity. But what's wrong with that? Well, oh, wait a second. Is there anything wrong with that? Which one of those is the lower number? The number that's further to the left on the number line. That number. So I need to write this as negative infinity to negative 30. Okay, negative infinity to negative 30. You always have your lower number and your higher number here, or better would be lesser, lesser, and greater. Okay, so in terms of our overall solutions, there is one solution, when m1 equals negative 30, negative 30, and m2, the second one, is positive 14. So negative 30 and positive 14 gives us one solution, a tangent. Zero solutions are when m is in between negative 30 and 14. That's a comma there. And then two solutions is the one that's a little more challenging. That's when m equals, it has two intervals. So from negative infinity all the way up to negative 30, and then usually we do a u for union, joining them. So for the union of negative infinity and negative 30, but also from slopes of 14 to positive infinity. Again, none of those are all round brackets because they don't include those numbers. Okay, so that's your summary of your solutions right there. All right, so hopefully that helps. And again, hopefully you're getting a good understanding of what's happening. This is really tough stuff. So go back, rewind, etc. as you need to. Okay, have a good day.